Hello, my name's Derek, and I'm going to show you how to use the mysterious user-defined functions in ANSYS. So, what are user-defined functions, and when do we need them? Well, let's say you're modeling a pipe, flow in a pipe, and you know that the fluid coming into the pipe has a certain profile at certain times. Then you can use a user-defined function to define that profile. Um, in my case, I'm using a user-defined function to alter the force or body term, as it's sometimes called in the Navier-Stokes equation, to model electromagnetic effects on a fluid flow, which is another typical case. And that's as an example I'm going to show you how to do today. So let's take a look at what a user-defined function looks like, the source file. So for those of you that are familiar with the C programming language, you'll recognize this as being C programming language code. If you're not familiar with C programming, it doesn't really matter. You don't need to be, because you're not really doing a lot. It's just calling a bunch of functions and writing the most basic code. So don't be put off. So to define a user-defined function for a source term, you need to use this syntax guy here. Not syntax, sorry. I just don't want to use too many programming terms, but this is a macro. You use this macro. So I've just pulled up the help for this guy. It's a bit hard to digest the documentation for ANSYS for the macros, so I'll just go through it quickly. So whatever you put here is going to be the name of your function in ANSYS. So once you load this guy in, you'll see test X, hopefully, and test Y for this guy. So you can define as many user-defined functions per source file as you want. Then often what you'll want is the location of the actual cell. So this gets called for every cell in the finite element method. So usually you define a vector of real variables, array of real variables, and then you call this macro here, and that puts the location of the x and the y location, if it's 2D, for the cell into this variable. If it's 3D, then the size of this guy will be 3. So that's why you're also using this macro nd underscore nd, which probably stands for number of dimensions. I'm going to take a random guess at. You can also print stuff off in macros for debugging purposes, but I don't recommend you do this for your final for your final solving, because it slows it down, as you'll see. And so I'll just go through the arguments. So this is simply just the name of your macro. This guy here is the cell number. This is the thread. You shouldn't have to worry about him. Here's the derivative, which you can make equal to whatever you want. But he's also a vector, I think, keep in mind. And this is the equation number, which you also shouldn't need. You just sometimes need these guys to call other macros, like this centroid one, depending on what you're using. You can call a bunch of different ones to figure out your temperature at the cell or the pressure. But keep in mind, if you had energy turned off and then you went to find the temperature at your cell, then that wouldn't be a very good idea, because you've turned off the temperature. So I'm not sure what happens in that instance, but you just need to keep in mind that some things won't be available depending on what solver you use. So how do we get this guy into ANSYS and apply it to a fluid zone? So I'll show you that now. So open up Fluent, and I've just got flow over the cylinder. Everything's sort of set up, and I want to now add the effects of our user-defined function. So this guy here. So I'll expect it, compared to the case with no user-defined function, that the x velocity will be slightly quicker, and the y velocity will be a lot more. Yeah, it'll the sort of fluid will be flowing up a lot and to the right. So you need to go into define, user-defined functions, compile. Now you won't see anything. You'll just see this. You won't see anything else, and you'll need to add the source file. So I just save this guy in one of the folders in the workspace, so I can easily navigate to from here, because it always opens up in this Fluent directory. So I just made another folder called source, and this is this guy, and you add him. And then you have to build your library, so it builds the actual DLL if you're familiar with C. And then you need to load your DLL. So if you're familiar with C, you'll know what that does. If you're not, it doesn't matter. You just need to know that you need to do that. And now you can see the two user-defined function names popping up, which should happen if everything's went well. If something didn't go well, there'll be an error, and it will tell you which line is wrong, which is quite handy. So an error code. Sorry. So I made a mistake. Yours will work if you're sort of rewatching this video and attempting this, but why mine didn't work is because I forgot to unload the library. So this is useful to know anyway. So say you make a change to your user-defined function, you'll need to go into user-defined functions, manage, and you'll need to unload the library. Yep. And now we'll try that again. Build. So you have to be careful. So it sort of doesn't look like it's failed, but what I think's happened is that it did fail, and I had a library that already existed, so the load library still worked fine, but the actual building of the library didn't. So now if I go load, cool, and now I know it's worked correctly. So now we need to tell ANSYS to apply it to the fluid zone. So you need to go into the cell zone conditions, fluid zone, and edit. And you need to go to source terms, and you'll get this message here, and it's because you need to have this checkbox clicked, and then you can add your user-defined functions. So it'll always show the applicable ones. So if I was going to I don't know if there's any others here, but say I was editing the velocity inlet boundary condition, then, and the magnitude, if I went to click edit, like if I selected that I want to use a user-defined function, then click edit, it'll pop up with the user-defined functions applicable if I've loaded the libraries. So now I click OK. And forget to initialize your solution and run the calculation. And you'll see all this printout. So there's a good chance the user-defined function's getting called if that's happening. So you can see that it makes it a lot slower printing stuff out, and you won't want to do this usually. So I just print out the cell number and the location. So I'm going to change that. Go here, just delete this stuff. Don't need it anymore. Save it. You make the fluent. Define user-defined functions, and remember we have to unload it first. So this is very tedious. I know some people do some fancy stuff with journal files, so they don't have to do all this stuff all the time. But I don't like using journals on the workbench. So compiled. Bunch of warnings, but everything's fine, no errors, and just need to load it. And we'll run our simulation again. And now there's no printout. You can see that that's gone now. I always recommend when you're working with user-defined functions to, so I'll show you in a second with the workbench, pops up, is to have a copy with the user-defined function and without, just normal, with no user-defined function, and then have another results component so that you can compare your simulation with and without a user-defined function and actually verify that it has some effect and it's doing sort of what you're expecting it to do. That makes sense. So now we'll compare with and without the user-defined function. Here we go. So with the user-defined function, and this is just normal, and we can see here that if you look here, the flow is symmetric or almost symmetric, whereas here you can see that the trailing flow is highly non-symmetric, and also at the front here, sort of saw yellow here, but not really yellow here, whereas you can see it's yeah, you can see the yellow here, and then the greens change too. So the user-defined function is definitely working. So I hope you enjoyed the video, and you can at least now load a code a user-defined function, load it, and then alter it, and then reload it, and compare with and without a user-defined function. Thank you.